Hello everyone, in today's video we are going to learn about damped oscillations and damped harmonic oscillator. Before that, welcome back to mahafarka.co.in. We know that when object oscillate, it oscillate with some natural frequencies. For example, if suppose you are enjoying the swing, तुम्ही झोक्यावर बसलाय and you are taking the swing to the left, then to right, and then you are oscillating again and again. So after some while, if you are not applying any force, then your vibration will goes on what? Decreases and will comes to rest. This will called free oscillation. Now vibrations with gradually decreasing amplitude but because of certain external force, then we can call them as what? Damped harmonic oscillator oscillations, and the corresponding unit which is to made for that certain purpose is called a damped harmonic oscillator. So here I have drawn already the damped harmonic oscillator, rigid support from which spring is suspended, and that spring is connected to certain load, like any hanger is there and mass is attached to that load. Okay, now that load is again connected to one T-shaped piston like material. We'll call it is vane. We are going to call it is what? Vane. Okay, that vane is allowed to strike to the water surface. So these are the things which is there. The beaker is there in which that vane will strike, and if suppose the spring is oscillate, the vane will come down, water will push it up, so that spring will get extra restoring force. So using this, see what is damped oscillations? We'll say oscillation with gradually decreasing amplitude. Oscillation with what? Gradually decreasing amplitude oscillations are called as what? Damped oscillation. Here, damped harmonic oscillator consisting of a spring with load or any mass. Okay. Then vane, which is allowed to fall into a beaker or vessel containing liquid. Liquid is preferred as what? Water. So how it is going to work and what should be the equation for damped harmonic oscillation, that we are going to find out. So as we know that spring is performing linear simple harmonic motion. So first I will consider for the case of spring. Let Fs be the restoring force exerted by the spring, or exerted by the material of the spring, whereas and K is the force constant of the spring. K is what? Force constant of spring. Now according to the definition of linear FHM, as spring is performing linear FHM, therefore if X is the displacement, X is what? Displacement of the spring from its mean position, then by definition I can say Fs is equals to minus Kx. Okay, that we can write for what? Spring. Now when that spring will come here, suppose this metal block come here, so that the vane will come down again and it will try to exert force on the surface of water. That vane when will enter on the water surface is trying to provide which force? Buoyant force, and trying to move it in which direction? Upward force. So I will call this damping force. More is the velocity of oscillation of that vane, more is the amount of damping force. So secondly I will write for vane. Let Fb be the damping force. Fb what? Damping force. Say V be the velocity of vane. Then as I say, more is the velocity by which that vane will fall inside the liquid, it will get opposed with more force. So I can say Fb directly proportional to V. Okay, so Fb equal to minus B into V, where B is damping constant. B will be what? damping constant. But we have reached to our basic assumption. Two forces, restoring force upward, damping force upward, restoring force downward, damping force also downward. So third case which I consider here, the resultant force acting on the entire system. Resultant force will be definitely sum of these two forces. So if I write them, what I am going to get here is F is equals to Fs plus Fb. Substituting value of Fs, it is what? Minus Kx plus minus Bv. So here it is minus Kx minus Bv. It is F. What is force is equals to resultant acceleration of the system if A is resultant acceleration of the system, then F equal to what? Mass into acceleration. What is acceleration in terms of displacement? If you remember, m into d2x by dt2. So substituting in equation number 3, what we will get? I will put the value of v also. So therefore I will say equation 3 becomes m into d2x by dt2 equal to minus kx minus dx b into dx upon dt, where dx upon dt means what? Velocity. Shifting all terms towards the left hand side, we will get m into d2x by dt2 plus b into dx upon dt plus kx equal to 0. This equation is called as a differential equation of damped harmonic oscillations. It is called as what? Differential equation of what? Damped harmonic oscillation. And this equation will useful for finding the numericals on the damped harmonic oscillation. I hope you understood this article, as it is very simple article. We need to just go through the basic assumption. Spring is connected to metal block in the form of load, and then vane. As the spring oscillates, the vane will try to enter into the water. Water will exert the buoyant force in upward direction. So that force exerted by vane on the water will be considered as damping force, and which is directly proportional to the velocity, which here I have written. So but these two things we have to keep in mind, and so that we can derive the differential equation for damped harmonic oscillator. I hope you understood today's video. Thanks for watching mahasarkar.co.in. Have a nice day.